and this is the more complex one. And I'm going to go through first the generic overview of what has been deployed. And so what we wanted to do with this particular exercise was to emulate a social media site. You're like, okay, this is our, I think we used Instagram or Twitter or whatever it is. And we have a bunch of developers at the top, and they've developed all of this stuff. And they're like, you know what, I'm going to put all of the social media code into a bucket, the virtual machine image bucket. So I have all of these assets, and that implements my social media site. I'm going to push them into a virtual machine image bucket. And then I am going to use a service account. So this is a developer service account doing this. I'm going to use a second service account, a compute that has the compute admin role, because this service account then needs to take the code in this bucket and deploy my site. And so this site is called, the virtual machine is called API engine, but it's basically a compute engine instance. It's a virtual machine that hosts the social media endpoints. And so what this service account does is it takes those source files in this bucket, deploys them on a new instance. And then this is the instance that's going to handle all of the endpoints for adding a user to the site, following a user, deleting a user. And then this code will then go into the database and then populate the backend database for the social media site. Okay. As part of all of this, we talked about centralized logging in order for you to understand what's going on in your application. All of these activities that you are doing will get logged to the cloud logging. And then there's a log viewer service account that's sitting there being able to examine the logs. Okay. So when this thing gets deployed, this gets all deployed, and then all of a sudden, the developer realizes, hey, there are these weird updates into this database that we don't know where they come from. It didn't come from the user who the status is attributed to. What happened? So that's the plot. And that's why we designed it. They're like, oh, this is an investigation. This is like CSI done on Google Cloud, but not as interesting probably for most people. So that's what we're doing. Okay, now this thing takes a long time to deploy. So yeah, deploy it, get a cup of coffee, or do something else, and then come back to it. What's really important though is for you to know the time that you deployed it. Because when you're searching the log entries, you got log entries from the entire duration of the project. Well, so the one thing is create a new project and then deploy it. And then restrict all your queries to the time range of when that project got deployed, so that you're looking at the minimal set of logs. We want this to be kind of realistic, but we don't want you to be like drowning in log entries. So that's the idea. Okay, so that is what we're doing. I have pre-deployed this level, because I don't want you to wait. I have pre-deployed this level in this project called Defender Audit. I'm going to restart this because I'm in the wrong project. I'm going to restart this shell. I'm going to put this back to 100%. Oh no, I'm still in Defender intro. So I can set the project ID, but what I wanted to do is if I'm in this project right now and I click on the Cloud Shell, it automatically sets the project ID in my parentheses. So that's why I typically don't do that command here. Okay, so the first thing that the Code Lab asks you to do is to take a look at the virtual machine instances. So I know that updates to this database are all done via the virtual machine. Like maybe I have set up the networking ACLs to only allow the database to communicate with this virtual machine. And so now I realize if I have these statuses that are going to this database that I have no idea where they came from, they probably started from the virtual machine. So I'm going to go and see where my API engine is. So I'll click on VM instances, and I'll be like, okay, where is this thing running? Oh, shoot, sorry. And so here's my API engine. It's at this IP address. I'm going to SSH into it. And say as a developer, I know enough about this application. It's basically a Docker container. That's what the VM image bucket does. It produces a Docker container, and then it deploys it onto the virtual machine. And the Docker container has all of my code in it, and it's the thing that interfaces to the database. And so I'm going to do some Docker commands. And again, if you're new to Docker, we just give you the Docker commands straight up. That's not the point of this class. One of the things you can look at is you can do a Docker PS to say, oh, this is the Docker container that's running this application. And it gives you the helpful name that, oh, Defender audit compromise. So it's like, oh, there's a compromised version of the container. That's probably why it's gone wrong. Like the adversary conveniently renamed the container to something that indicated it. And so you see the name of this thing. So you're all right, well, then maybe I'm going to do some forensic analysis. I'm going to do a Docker exec -it of the container name, which is klt.a6 fnld, and then I'm going to execute a bash shell on this thing. And so here I am in this container. I'm going to do a ps auxww to find out everything that's running. And so the only thing this container runs is my application. Looks like it's a Python application. It's got this Cloud SQL proxy for doing the database connections to. And then it's like, oh, whoa, look at this. This is the database name, the port number. I can see all that stuff go by. One of the things that I'm going to do is say, oh, well, what type of database is this thing running? I can actually go and see this database running down in Cloud SQL, which is part of the code lab. So the code lab is like, oh, go find where this database resides in the project. You found the name of the cloud instance in the command line, so it's user data DB instance is the name. Well, so you're gonna have your own ID here, but it's a Postgres SQL version 13, and then you can actually see this is the database's IP address. Okay, so that's the next part of the code lab that the code lab is asking you to do. One of the things you want to do is I have this process listing, but where can I get the code that's running here? So one of the things that the Linux proc file system allows you to do is to poke around to see where the working directory of each one of these PIDs is. So if I do an ls of /proc/1/cwd, current working directory of process with PID1, you can see it's being run out of /app. And so maybe I want to figure out, well, what's the working directory of the cloud proxy? I can do an ls proc 11 cwd. That's also being run in the /app. So all the stuff is in /app. So then I'm going to go into /app. And it looks like this is just a simple Python application, and it's got a Docker file for producing the Docker image. So they supplied that as well. And then this is some source code that's there. So I'm like, oh, well, that's interesting. Well, what's in this source code? And I'm going to do, there's not much on this container in terms of a pager or an editor. So what is there is more. So I'm going to use more. But if you're trying to Vim this, I don't think there's Vim. There's no VI. I don't think there's an edit. Oh, there is an edit. There's no less. Yeah, this is a bare bones container, but I'm going to do a more on this. And so you can see this is an example of someone doing the right thing and using a secret manager. So in this case, it's basically, you know what? I have a secret called Defender DB password, so that if I rotate the credential on my database, I don't have to change my code, right? Like, because I don't want the username and password hard-coded in this source file. And so what this developer has done is pretty good security. Is say, this is the name of my secret. I want you to just get the value of it from the secret manager. So this is just an example of that service that I mentioned earlier. So you're like, okay, well, this is like information about connecting to the cloud proxy. And then you can see, oh, the username is API engine, and the password is whatever I pull from the secrets manager, and that all works. That's not the point of this exercise, so I'm gonna move on. The first route that you see, these are Python Flask routes. This is actually implementing your web app. So it says that the /path accepts a post method and then creates a new user. So that's basically what this thing is doing. So that's interesting. There's a test route /test that just returns this HTML. That's not interesting. There's a /follow that implements the following feature. So that's not interesting. That actually is what I wrote, what I as the developer wrote. There's a delete that deletes a user. I'm like, okay, that works too. And then there's this helpful route called hacked, which is like, yeah, that's probably malicious code. And if you look at this thing, you're like, okay, well, what does this route do? It just basically connects to the database, and then it executes whatever string is submitted in the web form as part of a SQL field in that form. This is basically allowing anybody to, this is like SQL injection, intended SQL injection, right? I present you a form, because you're the adversary. You don't want to actually learn SQL syntax. I don't want to have to break syntax. I just want you to just take whatever I send you and then fetch. And so this is like, okay, so there's a backdoor into the SQL database. So that's the next part of the code lab. And you can say, well, what are all the routes here? You can grep for the string route in main.py, and then you'll basically get, these are the routes that the application has. And that's part of the code lab. And so I'm walking through all of the bolded, bulleted things in this code, this particular lab. Okay, so the next thing we want you to do is to actually go and look through the logs. You're like, how did this app get modified? Like, who is accessing this virtual machine to basically create a new Docker image and then force this virtual machine to now use it? So that's the next step of the code lab. So I'm going to put this aside, and then I'm going to go into the logging UI. So I'll go here to the logging explorer. And in the log explorer, you see, actually what I'm going to do is I'm going to restrict the log entries to be when I actually deployed this level. And I actually deployed this last night. So I'm going to cheat and set the range to the dates that I know this got deployed in. This was 8:15 p.m. And then this ended at 8, I think it was 27 p.m. Okay, and so you can see all of the logs. This is a ton of logs, like 20 minutes of logs, and you see there's like over 1,000. There's a couple thousand log entries. This is what detailed logging does to you, though. But again, you are required to maintain these logs for sensitive applications. So I know that this virtual machine got hosed. So I'm going to start with the virtual machine. I'm going to click on the virtual machine instance and see what are the fields that are involved with this virtual machine. And the thing asks you to click on severity notice, because there's a whole bunch of errors and warnings. You see a bunch of cruft in your logs. This is what, you know, that headline that said half of your time is wasted on useless data because there's too much of it. That's what it means, right? Like, if I didn't tell you to deselect notice, like, do you think you'd want to go through all of this stuff and realize that, yeah, this is not interesting? Like, it looks interesting, right? It's in red, but the UI doesn't know what's interesting or not. I'm telling you what's interesting because I don't want you to run away screaming from this class. I'm going to be hopefully guiding a little bit of this so that I can maintain interest without going over the top. So what is if you look at this sequence of log data, and so this is starting from the latest is at top. One of the things that you see in this sequence is that there's a whole bunch of stopping and starting of this instance, followed in between by a set metadata. And you're like, oh, that's not good. Somebody stopped this virtual machine and then restarted it after a set metadata. That's bad news. Yeah, so that's probably what you're looking for. And that's what I asked you, like, what is the service account that was used to change the metadata on that virtual machine? And so if you look at this metadata, you're like, proto payload authentication. Let me blow this up because it's going to be an eye chart. Maybe I'm the only one with bad eyes here, but like in case any of you are with bad eyes. So if you look at the authentication info, you'll see, oh, compute admin was the service account that was used, and then it was used to set metadata. Let me see here. This is the request. And then this is the metadata keys modified. And right here, the GCE, this is Google Compute Engine Container Declaration. Somebody changed the name of the container for this virtual machine to run, and then restarted the virtual machine, and then the virtual machine downloaded a different container than what it was originally doing. So that's the next, that's step 8 of the code lab that I want you. So that payload metadata is what I want you to find, and then the metadata delta is this container declaration. Okay. All right. So that's the next step. So one of the things that you know as a developer is that the container that's running on that virtual machine, well, that's built from the virtual machine image bucket. So there's a storage bucket that you know the developer has pushed the assets to, and then the compute admin service account just takes those assets and deploys them onto the virtual machine. But we want to see how this compute admin account got compromised. And so we know that it likely was deployed out of a virtual machine image bucket. So that's what we're going to do next, is basically go back to the query interface. And I know the bucket name. I can go and find it in cloud storage. I can go to the browser and say, well, what is the bucket name that's got the virtual machine image information, the Docker file and the Docker container, the source files. This is my bucket, virtual machine image bucket. So maybe I'll copy that. And I'm like, okay, I want to see who has accessed this. And so I can go and paste into this log field just this bucket name. What I can do is I can just clear, sorry, I'm going to clear these fields, and I can actually go and select from the GCS bucket logs. Yeah, filter this bucket name is what I want to do next. Okay, so when you go and you look at all the accesses to this virtual machine image bucket, you'll see a whole bunch of gets, lists. So create, there's a whole bunch of creates, which is me deploying the level. And then somebody lists the bucket information and then starts getting all the different objects from this bucket. And so you're like, oh, well, what's this one? They got the test file. They got the requirements file. They've got the main.py. So this is where they found out, hey, there's source code here that I can change. And so I'll just change it. And they look here and they're like, hey, look, there's a compute admin.json file. And so what happens is the developer is like, oh, I need compute admin access to deploy my software onto that virtual machine. Let me just stick the credentials in this storage bucket. Now, this storage bucket is probably hidden, right? Like it's probably ACLed, but still, this is encoded and stored in a bucket. So if anybody compromises the bucket, and we'll talk about how they compromise the bucket next, they can basically get access to the contents of that. And so what I want you to do in this part is just take a look at who did this. Right? Who is accessing these files? And if you look at the proto payload and the authentication info, you're like, oh, there's a dev account that's being used. So now that the adversary has managed to get a hold of this dev account, And moreover, a service account key that was issued to this dev account is basically what this next part is. And you can see that this is where that key was exposed. So that sucks. The resource, so if you look at the resource, it's a compute admin JSON file that was accessed. There's a couple other accesses here to basically get the Cloud SQL proxy file. And then this is the Docker file. These are all the contents in that bucket. So that basically gets them the complete contents of that. Okay, so I'm not going to do this because I'm running out of time. In the code lab, I show you how you would take this service account key, which sorry. I'm going to go to this storage bucket. I know that this compute admin JSON file has been exposed. So I'm going to click on this thing and be like, oh, I need to revoke this. So we saw how you revoke the key in the UI. So this is the compute admin JSON file, and you can see this thing when you look at it. This is the key ID, BED65. So now you need to go and delete that key ID off of that service account. And so what I'm going to have you do, I'm not going to do this right now live. I have you, based on the different service accounts that you, so you know that that key is associated with a compute admin. Based on that service account name, I'm going to list all the keys, and then I'm going to delete the one that got leaked, just using the gcloud commands to interface with your platform resources. And then
you revoke dev access to that same key, because you know that's how they got in, right?
So as soon as I delete that key, the developer, even though they can try and use that key, it won't be accepted anymore because I've deleted the credential. Yeah. And then I need to remove that. So I just wanted you to practice remediation. Knowing that this thing got leaked, you would want to go and delete these keys. So that's just part of the lab. Okay, I have 4 minutes left. God, I think I talked too much or slowly or. Okay, so now I want to look at all of the cases where the dev account was used and figure out how did the adversary get the dev account credentials. So I'm going to go back to the query interface, and I'm like, okay, well, give me all dev account, and I know the name of it because I already found it in the log files, and I'm going to clear these things. Well, hopefully, when I run the query, hopefully it clears all of those things.
You're still using the same time filter?
Yeah, so you see up here, I saved my time filter. And so you can see these are the accesses that I had before that were getting all the files using that dev account. And then you can see there's right before this stuff started happening, you have this log entry right here, and it's from this function, this cloud function called RM user 450209, etc. And you're like, hey, there's a log entry in here that got posted from this cloud function, and it's the action was remove user. If I expand this out, it's like, oh, that's not good. That looks like a private key. And anytime you see one of these things, you're like, that's not good. So what happened here? Turns out this is an error. It was an invalid request. And basically, this is someone hitting this endpoint with the private key of an account. Maybe they thought they were using an authentication token and were attaching or maybe they thought the thing needed an actual private key and instead of an authentication token. And so they instead sent their private key. And then this is the defender, or this is the private key ID. And this is the user, the dev account user. So you see this thing gets exposed in an unsanitized error message. And so one of the things that I want you to do is look at the code that produces this. So you know it's a cloud function. And so I'm going to go over here and then say, well, let me look at this cloud function and look at the source code of it to see how it's being used. So I'm going to go to this cloud function, and then I'm going to click on this function name. And then as part of your cloud function, you can get the source code of what's running there. So this is the source code of the thing that's running. And I can click on main.py, and this is the code. And so if you look at this code, it says it creates a logging client, and it gives it a name. Because when you're streaming logs to that log backend, you want to give it a name to organize and do the querying and the filtering on. And so you have given the log name RM user to this log, and you can see it gets some request information that requires authentication to be attached. And then if there is an error, I'm going to create this structure and then send it to the centralized logging. And so if there's any problem with this thing, I am just going to send all of that data back to the backend. Now, this is common, right? Like if something goes wrong in your application, this is what you want to have happen, right? You want to be able to get detailed logging information. The problem is if someone creates an error on this function as a result of attaching their wrong credentials, well, those credentials get automatically sent into the log data. And then anyone who is able to view the logs gets that credential out of the logs. This is an issue that's really hard to fix, right? Because you're basically like, it's hard to prevent someone from doing the wrong thing and attaching the wrong file. And then it's hard to debug something unless you get full information. So that's basically what's happening here.
Okay, I'm gonna go back since I have some extra time now because I'm doing this offline and not in class. We had basically discovered that a compute admin service JSON credential was left in a bucket. And so if you go into this bucket, you can see that this is one of the files that the adversary was able to pull out. And if you look at this credential, and bring it up in a browser, you can see that there it is. The private key ID is BED65, and then the actual service account is here. So this is how the adversary was able to get access to this service account and then deploy the image, the malicious image that we saw earlier. When you see something like this and you see that this credential has been pulled out of that bucket, and it wasn't by you, you immediately need to go and get rid of that service account credential. So that's what we're going to do next. So we're going to first find a list of credentials that have been issued to this service account. And again, we have the service account right here that I highlighted in the previous one. So we're going to go and just list all the keys that the service account has been issued. So I'll do that here in Cloud Shell. Where's my Cloud Shell? So here it is. Well, let me first. And then in the IAM account, I'm going to give it this service account client ID because that's the name of it. Whoops. Sorry. And then I'm going to list all of the service account keys that this particular service account has been issued. I have to authorize that as me. And this will return, these are the two service accounts, and this is the one that showed up in the bucket. So this is the one we're going to have to actually delete. And so they ask you in the code lab to go and delete that service account, or that key. So that's what I'm going to do. I'm going to say delete this thing. And then this is the key ID. And then this is the service account that the key belongs to. And then this will delete the thing. And I'll say yes. And that deletes the key. And then the next thing you would want to do is delete the file. I mean, if you use this key after I've already deleted it from an authorized key store here, it'll be useless, but you might as well go ahead and delete the thing. So that's what we're going to do. We're going to use gsutil to do that. So gsutil rm. And then we will use tab completion, hopefully, to to finish this, and then compute admin.json, and then we'll delete that file. Okay, so that's the compute engine credential being used or accessed, used, and now we have to go back and delete. Now, how did this access happen? And so we already went through this, and if you go into the logging, you can see that the developer account, the dev account, actually was the account that pulled all of the objects from the storage bucket. And when we search for that particular service account key that was used as part of the dev account to access those storage buckets, we can also see that it was leaked via this cloud function, and that's what where we left off. So we go back and we search for the dev account access, and so this was the access that that exfiltrated the compute admin JSON. And as part of this access, you can see that the access key is given here, the key that was used. So now we want to figure out how did the adversary get this particular key. So I'm going to copy this and search for this in the search query and see anywhere where it might show up. And it just turns out that this was leaked in a way that it actually shows up in this search. But you might have to do a more detailed audit if this is a key that you know has been exposed and you don't know where it's been exposed. It might not have been exposed in anywhere where your log entries can find, and then you'd have to do some deeper analysis. But I'm going to just, because I know this shows up in the log files, I'm going to search for this key. And you can see all of the accesses that this particular key has made, because now you can assume that all of these accesses are actually malicious because it was used to pull out this this compromised JSON file. And so you see these are the gets and the lists using that compromised key that we saw before. But then right before that, you see that there is an entry from a cloud function that seems to have this key show up in it. And so this is the entry here. It's this cloud function. And then you can see this key show up in this log file. And so this is a key that was left unsanitized in this entry, which I had explained earlier. And so now this might be how the adversary got a hold of this key. It was in an error message, unsanitized. So the next step is to see who was accessing the logs that might have read this log entry. And if you look at this log entry, one of the things that I ask you to do in the code lab is to look at the logger. And so we see that it's bound to this cloud function. So when you click on this function and you look at the source code, you see that the logger that gets created has a name, and the name for the logger is RM user. And so you can see in this log entry that this function has generated, you can see this name show up in the audit data. So this is the entry here. This is the cloud function. You see the payload, which is this rogue or this accidental leaking of this key. But then if you go into the JSON payload, you can see the action, the auth, and the error message, and the logger name. And so now you see that the logger field that contains anyone's read to this entry is going to have this RM user logger that's being retrieved. Now, the adversary could have asked for every single log and then gotten this as this data, or in this case, the logger might have searched for this log data, in which case any kind of search that is targeted to this name might be something that actually shows up in your audit data. And as it turns out, Google Cloud Logging can be set up to log accesses to Google Cloud Logging. And if you, the service account that we saw earlier that was set up to view the logs was that log viewer account. So we can look for accesses based on the log viewer service account, if you recall that service account that was being used for this project to do so. And then you can see a whole bunch of, these are the different logs associated with this, the access of this site. And so you can see some of these log entries is list log entries. And so that might be an interesting log event for you to drill down deeply in. So there's several of these list log entries. And so that's one way to figure out who has accessed your logs. If you believe the logs were accessed very targeted, in a targeted way using the logger name, the other thing you might search for is the name of the logger, which was RM user. And so I can do the same query. And as it turns out, this query is going to give me back the same entries. And so well, it'll give me a subset of the previous ones, because the previous ones is looking at all of the accesses that the log viewer had. This is targeted at just the accesses to the RM user log. And so that's what these things are. And the actor who has done these list log entries, or these logging accesses, that actor likely is the person who stole the key and is doing the malicious things. And then you would have to backtrace from there to find, well, who is the responsible party initiating these log reads. And so let's drill deeply into each of these log entries. If we expand out this one, you see it's a list log entry. And then this is the payload that's given, and you see the authentication information. This is the actor, and you see it uses the log viewer service account that we had set up earlier to view the logs of the project. And you see that it also has a service account key that was used to do this access. So the adversary somehow got access to this key and then was using this key to list the log data of the log entries. And then you might be interested in seeing what exactly was being requested, and that's what you can find here in the proto payload request. And you can see the filter associated with this request, which is what the code lab is going to ask you to identify, has right here the log name that I'm interested in is an RM user, and at a particular timestamp greater than or equal to this date. And so this probably is the entry that the adversary, this logs the entry of the adversary accessing the RM user logs and finding the developer key. Now, in this particular code lab, that's where our analysis stops. Obviously, you could go one step further and say, well, let me find out who has used this particular key to access things. And as it turns out, it's our emulated deployment manager thing, because we had to, this is all automated from that deployment manager script. So we're going to end here. But like if this was actually like a regular ThunderCTF level, maybe you would activate this service account first. Like if you were the attacker and we set this level up for you to attack, you would be doing the reverse process. You would start with a innocuous key, which is like, oh, I'm just viewing the logs. You would elevate your privileges to become the developer, because the developer made a mistake and emitted his private key instead of attaching a token. And then from there, as a developer, you see that, oh, the developer put the compute admin credential in the bucket that the developer had access to. Then you would go and you would grab that credential, and then you would use that credential to replace the virtual machine, and then onwards to changing the source code, and then sending out rogue statuses, which is basically the other side of that chain of events that we just unraveled. Okay, so with that, that's all of the Defender audit level. Sorry about having to split this up into two halves. Hopefully it still makes sense to you, everything that we did and sort of why we're covering this, because it does let you see how privilege escalation can be done in a project. Lateral movement and privilege escalation is basically what was happening inside of this particular cloud project. And then it gives you an idea of the kinds of remediation that would be necessary to undo this damage, like getting rid of all the keys, telling the developer to stop putting credentials in storage buckets, and these sorts of things. So hopefully this was instructive and it can get you through this code lab without too many issues.